Hello everyone, good evening. So here we shall solve some more JEE Mains previous year questions on the chapter sets and relations. So still, any doubts if you have in any steps, then please write that in the comments. We shall obviously clarify them in the subsequent videos or in any other chapter of maths. If you have more difficulty, then please mention the name of that chapter also in the comments section. So here it is told that S equals to 469. S is the set 469 and T is the set 9, 10, 11 till 1000. And A is the set of the sum of A1, A2 till AK, where K belongs to N, and A1, A2, A3 till AK, they belong to the set S. Then the sum of the elements, then the sum of all the elements in the set T minus A is equal to how much? Okay, that we have to find out. So here it means these elements A1, A2, A3, AK, these should be either 4, 6 or 9. So it means here, let's say 4 can come X number of times, 6 can be added Y number of times, and 9 can be added Z number of times. Therefore, this sum, which is A1 plus A2 plus till AK, this can be written as 4x plus 6y plus 9z. If 4 comes x number of times and y comes and 6 comes y number of times and 9 comes z number of times, since there are only three elements in the set S. So now therefore any element uh, and here x, y and z should be obviously natural numbers, since x, y and z is the number of times which 4, 6 and 9 are respectively added in every element of A. So any element of A is of the form 4x plus 6y plus 9z. Okay. And x, y and z should be whole numbers, since x, y or z can be 0 also. So x, y and z should belong to the set of whole numbers. So therefore the elements in the set A, they can be of the form, like we can take, if x is 1 and y is 0 and z is 0, it can be 4. Then if it can be 6 also, or it can be 9 also, or it can be 4 plus 6, that is 10 also, etc. And it can be 6 into 2, that is 12 also, etc. So now there is a rule that the value of, or I can say the expression, the linear expression, l- the linear expression which is ax plus by will have all values greater than or equal to, will have all values greater than or equal to a minus 1 into b minus 1. So so it is a rule that the linear expression ax plus by will have all values greater than or equal to a minus 1 into b minus 1 for for all for any x comma y belongs to whole numbers. And here x and y, they both should not be okay, where x and y belongs to n. So therefore, this 4x plus 6y plus 9z, and here a and b should be some prime numbers, and where a and b should be prime numbers. So here also 4x plus 6y plus 9z, that can be written as 4x plus 3 into 2y plus 3z. Now the number, so therefore expression, the expression 2y plus 3z, here 2 and 3 are obviously prime numbers. Yeah, and okay, here a and b should be co-prime numbers, co-prime. Okay, then the expression 2y plus 3z, that will have all values uh, greater than or equal to 2 minus 1 into 3 minus 1, which is equal to 2. So it means its value will be more than or equal to 2. Uh, Therefore, this 2y plus 3z, we can write it as t plus 2, where t is some, for some t belongs to whole numbers. So it means it is always more than or equal to 2. So I can write it as t plus 2. So therefore, this 4x plus 3 into 2y plus 3z, that we can write it as 4x plus 3t, 3 into t plus 2, which means it is 4x plus 3t plus 2, 3t plus 6. Sorry. So now similarly, this expression 4x plus 3t, now 4x plus 3t, here 4 and 3 are also co-prime since their HCF is 1. So 4x plus 3t also, its value will be more than or equal to 4 minus 1 into 3 minus 1 for all x comma t belongs to n, which means it's it is 3 into 2, that is equal to 6. So therefore its value is more than or equal to 6. Therefore 4x plus 6y plus 9z, that will be more than or equal to, this will, its minimum value is 6, so it will be more than 6 plus 6, which is 12. So its value will be more than or equal to 12. So all values it will contain more than or equal to 12 also. So therefore, yeah. So therefore t minus a. So therefore a will contain 12, 13, 14, all till 1000. Now these, if we subtract from t, then so therefore t minus a, that will be only 11, since 9, 10 is already there in a. So t minus a will be only 11, since only 11 does not belong to the set A, but it belongs to the set T. Since 11 belongs to the uh, set T, but 11 does not belong to the set A. So 11 is the only element in this set. So the sum of all the elements in the set T minus A, that will be 11. Then here it is told that the set A equals to 1, 2, 3, 4, 5, 6, 7, and B equals to 3, 6, 7, 9. Then the number of elements in the set C is a subset of A. Then so the number of elements in the set C where C is a subset of A and C intersection B, that should not be 5. So C intersection B, so all subsets of A whose intersection with B should not be 5. So we have to take those subsets of C, those subsets of A, whose intersection with B is not equal to 5. It means all elements in A we can take except 1, 2, 4, 5. 1, 2, 4, 5. 1, 2, 4, 5. Since 3, 6, and 7 is already there in B. So except these elements, we can include in the set C. So therefore, the number of elements in the given set, that will be equal to the number of subsets of A, the total number of subsets, the total number of subsets of A minus the number of subsets of 1, 2, 4, 5. The number of subsets of the set 1, 2, 4, 1, 2, 4, 5. So we have to find the number of subsets of A minus the number of subsets of 1, 2, 4, 5. Now the number of subsets of A, that will be, there are 7 elements, so it will be 2 power 7 minus the number of subsets of these 1, 2, 4, 5, that will be 2 power 4. So that will be 2 power 4 into 2 power 3 minus 1. So this will be 16 into 8 minus 1, that is 7. 7 6 42, 7 1 7, 112. So there are 112 elements in the set. Then here it is told A is the set 1, 2, 3, 4, 5, 6, 3, 4, 5, 6, 7, and B is the set of all those T, such that T is a subset of A and either 1 does not belong to T or 2 belongs to T. And C is the set of all those all those subsets of A, such that the sum of all elements of T, is a prime number. It's a prime number. So now the number of elements in the set B intersection C is. So now, therefore, the number of subsets of A, containing 2, means which is either containing 2 or not containing 1. Not containing 1. So that will be equal to the number of subsets of A containing 2 plus the number of subsets of A containing or not containing 1, minus the number of subsets of A num- minus the number of subsets of A containing the number of subsets of A not containing 1 and containing 2, not containing 1 and containing 2. So here AND function is used. It means we are taking the intersection of these two sets. Now the number of subsets of A containing 2, it means except 2 I can, so 2 I have to take, and other elements I may or may not take. So it means I have got uh, 1, 2, 3, so 6 out of 6 elements any I can take. I have got 6 options to choose. So it means the number of subsets of A containing 2, that will be 2 power 6, plus the number of subsets of A not containing 1. So except 1 I can choose any of the other 6 elements from 2 to 7. So that will be also 2 power 6, minus the number of subsets of A not containing 1 and containing 2. So it means these two we should not take 1, and 1 and 2 we should take. So we have got 5 options. So it means the number of subsets will be 2 power 5. So it means the number of elements in the set B, which is the number of subsets of A either containing 1 or not containing 1, means either containing 2 or not containing 1. So therefore the number of elements in the set B, that will be 2 power 6, that is 8 8 is 64, plus 64 minus 32, so that is 64 plus 32, that is 96. Then C is the C is the subset, all the subsets of A, such that C is the set of all subsets of A, such that the sum of all elements of T is a prime number. So for let's say if the sum is 2, if the sum is 2, then we can have only 2 we can take, and same elements we can't repeat. So here we have only one set, one such subset of, we have only one such subset of A, whose where the sum of the elements is a prime number. So now sum, suppose it is 3. So here we can get 3 we can take, or 1 and 2 we can take. So here we have two subsets of A who where the sum is a sum of the, so here sum of the elements should be prime. Some of the elements of the subset of A should be prime number. So that we have to check. So now sum, if it is 5, 5 is also a prime number. So let's say we can take 5, or we can take 1 and 4. We can take 2 and 3 also. And we can take 1, 2, 5 also, you can 1, 4, we can take 2 and 3, you can take. So these only we can take. So there are 3 subsets. And then the sum is 7. So 7 we can get how? We can take only 7, or we can take 2 and 5, or we can take 3 and 4, or we can take 1 and 6. And then we can take 1, 2 and 4, or we can take 1, 2, and 4 we can take, and 1, 2, and 4 also we can take, and 3 elements. So 3 elements, 1, 2, and 4 we can take, and 1, 5, no, 6. So same element can't be repeated. So here also we can have 3, 4, 5 subsets. Then when the sum is 7, 8, 9, 10, 11. So if the sum has to be 11, then we can take 4 and 7 we can take. We can take 5 and 6 also. And we can take 1, 2, and no, 1, 3, and 7 we can take. Then 2, 3, and 6 we can take. And then 2 and 2, 4, and 5 also we can take. And then 1, 4, and 6 also we can take. Then 3, okay, 3, 4, and then 4 only, 3, 5, 3, 3, 6, and 2, but we have already taken that. Okay, so here it means we can have 1, 2, 3, 4, 5, 6 subsets. Then the is sum can go maximum till 13. So since 13 is a prime number, no, sum can be okay. 2 elements. For 2 elements, it can be maximum 13. B intersection C. B intersection C. The sum of all the elements in A, that will be 7 into 8 by 2. That is 4 7 is 28. So the prime number just less than 28, that is 5, 23. So till maximum 23 it can go. So when the sum is 20, if the sum is 13, then we can take yeah, 6 and 7 we can take. And then we can take 1, 3, and 9. 1, 3, and 9 we can take. And then 1, 4, and 8 we can take. Then 1, 5, and 7 we can take. And then 2, 3, and 8 we can take. Then 2, 4, and 7 we can take. Then 2, 5 and 6 we can take. Yeah. Sir. ठीक है. So the sum is 13. So in this way, we shall take till the sum is 23. And then, so after 13, we will tell that the sum is 17. Then we will have sum is 19. Then we will have sum is 23. So if we add all these, then we will get uh, 42 subsets of A. 42 subsets of A we will get. So it means the number of elements in the set C is 42. And then we have to find the number of elements in the set B union C. So therefore, the number of elements in the set B union C, that is equal to the number of elements in set B plus number of elements in set C minus the number of elements in B intersection C. So B intersection C, it means those elements in C which are having 2 as one of its elements and which are not having 1 as one of its elements. So that if we count, then this we will get 31. So then this will be B will be 96 minus 42, 96 plus 42 minus 31. So this will be 96 plus 11. So that will be 107. So the answer will be 107. Then here it is told let R1 and R2 be the relations on the set A, which is 1, 2, 3, 4 till 50, such that R1 is the relation which contains P comma P power n, where P is a prime and n is greater than n is greater than or equal to 0, n is an integer, and R2 has P comma P power n, where P is a prime and n can be 0 or 1. And R1 minus R2 is. So R1 minus R2, it means that it will have, it has those elements P comma P power n such that P is a prime, P is a prime and n is greater than or equal to 2 and n is an integer, since n should not be 0 or 1. So therefore, therefore 2 is a prime number. Therefore, we can say the elements in the set R1 minus R2 are, it will be 2 comma 2 power 2 and then 2 comma 2 power 3 and 2 comma 2 power 4, 2 comma 2 power 5, 2 power 5 is 32 and 2 comma 2 power 6, it is 8, it is 64. So which we can't take. So till 2 power 5 we can take. Similarly, and we can have 3 comma 3 power 2 and 3 comma 3 power 3 and 3 comma 3 power 4 we can't take, since y 3 power 4 is 81. Then we can have 5 comma 5 power 2 we can have. 5 power 3 we cannot have. Then 6 is not a prime. 7 is a prime number, so 7 comma 7 square we can have. Then 7 8 9 10 11. 11 is a prime number, so 11 comma 11 square we cannot have. Then 13 comma 13 power 2 also we can't have. So therefore these are the elements. Therefore 1 2 3 4 5 6 7 8. So there are 8 elements in R1 and R1 minus R2. And here it is told A is a set which contains all those elements n such that HCF of n and 45 is equal to 1. So it means that we can have 1. So the 45 is actually 3 powers 2 into 5. 5 power 1. So it means that it should not have 3 or 5 as its factors. So it contains all those natural numbers which is not having 3 or 5 as its factors. So I can take 2 also. 4 I can take. 5 I can take. 6 I can't take. 7 we can take. 8 we can take. 9 we can't take. 10 we cannot take. 11 we can take. 12 we cannot take. 13 we can take. 14 we can take, etc. And so on, like this. And then so n, so it contains all those n where n is not a, it contains all n such that n is not having 3 or 5 as its factor. Then B is the set which contains all those 2k such that k belongs to 1 to 100. So it contains all the even numbers from 2 to 200. So it contains the elements 2, 4, 6, 8, 10 till 200. 2k where k belongs to 1 to 100. Then the sum of all the elements in A intersection B is. So here actually we should take only the even numbers. So B equal to 2k, it means that it should be an even number from 1 to 100. Oh, sorry. Yeah, it is an even number and it would go from 2 to 100. So now, so therefore, the sum of all the elements in A intersection B, that will be equal to mm, so if we need those numbers whose HCF with 45 is 1. So this will be the sum of all the numbers, all the even numbers from 2 to 100, 2 to 200, which are having, which are mm, which are co-prime with the number 45. It means that which is having HCF 1 with 45. So therefore that will be equal to 2 into sum of the natural numbers, sum of the natural numbers up to 100, sum of the natural numbers up to 100, which are neither divisible by 3 nor by 5. So therefore that will be equal to 2 into all the sum of all the numbers from 1 to 100, from 1 to 100, that minus the sum of the numbers which are divisible by 3, which are divisible by 3 from 1 to 100, and minus the sum of all the numbers which are divisible by 2, which are divisible by 5 from 1 to 100, then plus the sum of all the numbers which are divisible by 15 from 1 to 100. So that will be equal to 2 into the sum of all the numbers from 1 to 100. So that will be equal to all the natural numbers from 1 to 100. So that will be 100 into 101 by 2, since the sum of n natural numbers is n into n plus 1 by 2. And similarly here, now this will be the sum of like 3, 9, 3 plus 9 plus 12 plus, then this is 99, then minus some of the numbers which are divisible by 5, which are from 1 to 100, so it is 5 plus 10 plus still 100, and plus some of the numbers which are divisible by 15, so that is 15 plus 30 plus till 15 7 is 105, and 15 6 is 90, so till 90 it will go. So this will be equal to 2 into 100 into 101 by 2, minus this will be 3 into 1 plus 3 plus yeah, so here 6 also will be there, 1 plus 2 plus 3 plus till 33, then minus this is 5 into 1 plus 2 plus till 20, then plus this is 15 into 1 plus 2 plus till 6, so this will be 2 into 100 into 101 by 2, minus 3 into, this is 33 into 34 by 2, minus this is 5 into n plus 1 by 2, this is 20 into 21 by 2, plus 15 into 6 into 7 by 2. So this 2 will get cancelled, then 2 will cancel out if you take half as common outside. So this will be 10,100 minus 3 into 33 into 34, that is 99 into 34, minus this is 100 in 2100, plus this is 15 6 are 90, 7 9 is 63, 630. So if we solve it, then we will get 5264. So the answer is 5264. Then here it is told, let A equals to the minimum of I comma j, where I goes from 1 to 10 and j goes from 1 to 10, and B equals to maximum of I comma j, where I goes from 1 to 10 and j also goes from 1 to 10. So therefore A plus B, now A is what? A is the sum of the minimum out of I comma I and j, where I and j go from 1 to 10. And I comma j is a natural number also. And B is the sum of the maximum out of I comma j, where I comma j is from 1 to 10. Then A plus B is equal to. Now, so we shall start with 1. So therefore, the pairs that will come, that is 1 comma 1, 1 comma 2, then 1 comma 3, until 1 comma 10 it will go. And then we'll start with 2, 2 comma 2, 2 comma 1, 2 comma 2, etc. till 2 comma 10. Then for 3 also. And then lastly, we will have with 10, 10 comma 1, 10 comma 2, etc. till 10 comma 10. So now when we add A plus B, it means it is summation of I goes from 1 to 10, summation of j goes from 1 to 10, minimum of I comma j plus maximum of I comma j. So A plus B is the sum of the minimum of I comma j and the maximum of I comma j. So for one, uh, 1 is the maximum in only 1 comma 1, in only one elements, in only one element, and 1 is minimum in uh, 1 comma 2 till 1 comma 10, and also in 2 comma 1, 3 comma 1, till 10 comma 1. So it means that it is minimum in 19 elements. Therefore, one is minimum and maximum in 20 elements in A and B both. In A and B both. Similarly, for 2, for the element 2 is minimum in 1 comma 2 and 2 comma 1. So it means in 2 elements, and 2 is maximum in 2 comma 2 and in 2 comma 3. 2 is, sorry, here actually we should write 2 is maximum. 2 is maximum in only uh, 2 elements, which is 2 comma 1, 2 comma 1 comma 2, 2 comma 1, and 2 comma 2 also. And 2 comma 2 also means in 3 elements. And 2 is minimum in 2 comma in 2 comma 3, in 2 comma 4, in 2 comma 5, and then till 2 comma 10, and also in 3 comma 2, 4 comma 2, 5 comma 2 till 10 comma 2. So it means that in mm, so here we have 3 to 10, that is 8 elements, and here also 3 to 10, that is 8 elements. And also in 2 comma 2 also. So it means that 2 is minimum in 17 elements. So therefore 2 is maximum and minimum in also 17 plus 3 in 20 elements. Since why you have to add this 17 and 3. Similarly, 3 is maximum and minimum in 20 elements. And so we can say that all the elements 1 to 10, so every element in the set S, yeah, in the set 1 to 10 is maximum and minimum. Every element in set 1 to 10 is maximum and minimum in 20 elements in sets A and B. So therefore A plus B, for A plus B, that will be equal to, and all those elements we have to add. So it means that it will be 1 plus 2 plus till 10 and into 20, since every element is coming 20 times. Every element is maximum and minimum in 20 ordered pairs. So therefore 1 to 10, the sum is 10 into 11 by 2 into 20. So it is 2 tens are 20. So 11 into 100, that is 1100. So the sum of A and B is 1100. Then here it is told the sum of all the elements of the set alpha belongs to 1 comma 2 comma till 100, and ACF of 2 and the ACF of alpha and 24, that is 1. ACF of alpha and 24, that is equal to 1. So it means that alpha and 24, they should be co-prime. It means they should have no common factor other than 1. So now 24 can be written as 3 into 2 power 3. Since why 3 8s are 24. So it means what? So alpha should not have, so it means that alpha should not have any, should not have 3 or 2 as its factors. So therefore, let's say this set is A. So then we have to find the number of the sum of all the elements in the set A. So here alpha belongs to 1 2 3 4 till 100, where HCF alpha and 20 and 24, that is equal to 1. So now therefore the elements will be 1 we can take, 2 we cannot take, 3 we cannot take, 4 we cannot take, 5 we can take. So simply we can say that this will be equal to the sum of the elements, which is sum of all the elements in set A minus the sum of mm, sum of all the elements in A which are divisible by 3 minus sum of the elements which are divisible by 2, of all the elements which are divisible by 2, then plus sum of all the elements which are divisible by 6, all the elements which are divisible by 6. So therefore the sum of, okay, l- l- let's say we take this as the set S. Okay, so we have to take set S, sum of all the elements in set S. S is 1 to 100. The all natural numbers from 1 to 100, let's say that is set S. So we have to find the sum of all the elements in set A. Sum of all elements in set A. So that will be equal to the sum of all those elements which are neither uh, all the elements in the sum of all the elements in set S which are neither uh, neither divisible by 2 nor divisible by 3. Therefore, the sum of all the elements in A, all the elements in set A, that would be equal to the sum of all the elements in the set S. So that is 100 into 100 into 101 by 2. Okay. So this is 100 into 101 by 2. Then minus the elements, sum of the elements which are divisible by 3. So that is 3 plus till 100. 3 plus 6 plus 9 plus till 99. Minus which are divisible by 2, which are 2 plus 4 plus 6 plus till 100, plus those which are divisible by 6. So that will be 6 plus 12 plus 16 6 96, 17 6 is 102. 17 6 6 7 42, yeah, 102. So we can't take that. So till 96 it will go. So this we have to find. So this will be 50. So 5050 minus this is 3 into 1 plus 2 plus till 33, minus this is 2 into 1 plus 2 plus till 50, plus this is 6 into 1 plus 2 plus till 16. So this is 5050 minus 3 into, this is 33 into 34 by 2, minus this is 2 into 50 into 51 by 2, plus this is 6 into 16 into 17 by 2. So 2 and 2 will cancel out. 2 17 is 34, 2 3 is 6. So this is 5050 minus 17 3 is 51 into 17, 17 3 is 51 into 33. Minus this is 5 1s are 5, 5 5s are 25, 2550, plus this is 6 is 48, or 17 3 is 51, 51 into 16. So this will be 2550, then minus 51 into 33 minus 16. 33 minus 16 is 17. So this is 2550 minus 51 into 17. So that is 2550 minus 17 ones are 17. 17 5 is 85. So 86. 865. So 2550 minus 867. So that is 3. 7 7 2 is 14. 8 9 6. So 1683. So we have to find those numbers which are not divisible by 3, not divisible by 2, not divisible by 2 or 3. So 550, then this is minus 51 into 33 plus 16, 33 minus 16, which is 1683. So the answer is 1683. Which is 6 into 6 into 16 into 17 into 17 by 2. So 2 3 is 6. P1 into 17, that is 17 minus 17, 17 5 is 35, 85, so 86. So 2550 minus 867. So this will be 3, 7, 8, 9. So 1683. Okay, 1683. Then here it is told which of the following is not correct for relation R on the set of real numbers. X comma y belongs to R if and only if mod x minus mod y is greater than 0 and less than or equal to 1, is neither transitive nor symmetric. Mod of x minus y from 0 to 1 is symmetric and transitive. So we have to check if that is symmetric and reflexive or transitive or not. So when mod x minus mod y is greater than or equal to 0, less than or equal to 1. So in this relation R, x is not related to x. Since mod x minus mod x that is equal to 0, so x is not related to x. So it means that R is not reflexive. R is not reflexive. So it means option C is obviously wrong. Then is it symmetric? We have to check. So now if mod x minus mod y is from 0 to 1, then mod y minus mod x, that will go from -1 to 0. So it will not go from 0 to 1. So it means that the relation R is not symmetric. R is not symmetric. Now is it transitive? We have to check. So if mod x minus mod y is from 0 to 1, and also mod y minus mod z, that is also from 0 to 1, also from 0 to 1, then we can't say that mod x minus z will be from 0 to 1. Since why? For example, if we take x as 1, if we take x as 1 and y as 1, y as 1.8 and z as 2.7, then mod x minus mod y, or suppose we take x as this, x as 1.8, y as 1, y as 1. No, sorry, it's slightly wrong. Suppose we take x as 2.7, y as 1.8, and z as 1. So now therefore mod x minus mod y, that will be equal to 2.7 minus 1.8, that is equal to 0.9, which is obviously from 0 to 1. And also mod y minus mod z, that is equal to 1.8 minus 1, that is also 0.8, which is from 0 to 1 only. But here mod x minus mod z, that will be equal to 2.7 minus 1, which is 1.7, which is not in between 0 and 1, which is more than 1. So it means that R is not transitive. Therefore the relation R is not transitive. So it means that the relation R is neither transitive nor symmetric. So A is the correct statement, but here it is asked which one is not correct. So option C is not correct. C is correct. Since why? Here actually it is told mod x minus mod y is less than or equal to 1. So mod x minus mod x is coming 0, which is obviously less than or equal to 1. So C is also correct statement. Now for option B and D we have to check. Now if the relation R is, if x is if the relation R is like this, that is mod x minus mod y, no sorry, mod of x minus y, that is from 0 to 1, mod of x minus y, that is from 0 to 1, is symmetric and transitive. So to check it, so now if I take mod x minus y is only less than or equal to 1, which is in option D, and this one is in option B. So for option D, here mod of x minus x, that will be equal to 0, which is obviously less than or equal to 1. So here this R is reflexive, but this R is, this relation is not reflexive. And if mod of x minus y is from 0 to 1, then we can also say that mod of y minus x, that will be also from 0 to 1. So it means that the relation R is symmetric. Relation R is symmetric. So R and this relation is also symmetric only, since mod of y minus x also will be less than or equal to 1. So this relation R is reflexive and symmetric. Reflexive and symmetric. So option D is also correct statement. So it means option B is not correct, since why it is told this is symmetric. This is symmetric, but it is symmetric, it is true, and but it is not transitive, since why, for example, suppose we take x equal to 2.7, y equal to 1.8, and z equal to 1. So now mod of x minus y, mod of x minus y, that is obviously mod of 2.7 minus 1.8, which is 0.9, which is less than or equal to 1, and more than 0 also. And also mod of y minus z, which is mod of 1.8 minus 1, that is also 0.8, which is also less than or equal to 1. Uh, but mod of x minus z, if you do, then it will be 1.7, which is not less than or equal to 1. So it means that the relation R is not transitive. It is not transitive. But here in the option B, it is told it is symmetric and transitive. So this is the wrong statement. So option B is the correct answer. And here it is told, out of all the patients, out of all the patients in a hospital, 89% are found to be suffering from heart ailment, and 98% are suffering from lungs infection. If k% of them are suffering from both ailments, then k cannot belong to the set. Out of all the patients in a hospital, 89% are suffering from heart ailment. So let that be the set A. A is 89% and suffering from heart ailment, and 98%, that is set B, it is they are suffering from lungs infection, and k% of them are suffering from both ailments, then k cannot belong to the set. So it means that uh, the percentage of A intersection B, it means they are suffering from both elements, that is equal to k%. So therefore, as you can see that A union B, that should be obviously, means the number of patients who are either suffering from heart ailment or suffering from lungs infection, that should be obviously less than or equal to 100%. So therefore, n of union B, that is n of A plus n of B minus n of A intersection B, that should be less than or equal to 100%. So now n of A, that is 89%, n of B is 90%, and n of A in intersection B is k%. So that means 89 plus 98 minus k, that is less than or equal to 100%. It means k should be greater than or equal to 89 plus 98 minus 100. So 98 minus 100 is minus 2. So K should be more than or equal to 87%. So K should be more than or equal to 87. And K cannot belong to the set. So K should be more than or equal to 87. So here we have 89. So it can be the value of K. And here also 88, 90 is there. So it can be the value of K. But here there is no value of K which is more than 87. Here also 87, 90, 93 is there. So it means option C is the correct answer, since K cannot belong to this set, since K should be more than or equal to 87. And here there is no such value in this set which is more than or equal to 87. Then here it is told, let n be the set of natural numbers and a relation R on n be defined as R. So x is related to y if x square x cube minus 3x square y minus xy square plus 3y cube, that is equal to 0 for all x comma y belongs to n. Then the relation R is. So from here we can say that this will be here we can factorize it. So this will be x square into x minus 3y minus, from here y square I can take common, and this will also come x minus 3y, that is equal to 0. So here we will get x minus y into x plus y into x minus 3y, that is equal to 0. So it means that x can be equal to y, or x can be equal to minus y, or x can be equal to 3y. Then only it is in the then only x comma y will belong to the relation R. So if any of these three conditions are satisfied, then only we can say that the ordered pair x comma y will belong to the relation R. Will belong to the relation R. Now the relation R is, so x, will it be related to x? Yeah. So x is related to x, since x is equal to y is satisfied here. So therefore R is reflexive. R is reflexive. And also if x is related to y, then y will be also related to x. Y will be also related to x, since y uh, it is not true, then y is not related to x. Then y is not related to x. Not related to x. Since why? Since suppose for example if we take x equal to 6 and y as 2. X equal to 6 and y as 2. So now therefore 6 equal to 3 into 2. So x is equal to 3 into y. So 6 is related to 2, but 2 is not related to 6. Since why? Since 2 is not equal to 3 into 6. So therefore R is not symmetric. R is not symmetric. Similarly, R will not be transitive also. Suppose for example, if you take x as 6 and y as 2, it should be natural numbers. Okay, so we take suppose x as 18. Since here x and y all should be natural numbers, x and y should be natural numbers only. So so if x is equal to 18, y equal to 6, and z equal to suppose 2, so then we can say that x equal to 3y and y also equal to 3z. So it means that x is related to y and y is also related to z. Uh, but 18 is not equal to 3 into 2. So it means that 18 is not related to 2. So it means that x is not. So I can say that here 18 is related to 6 and 6 is related to 2, but 18 is not related to 2. So it means that R is not transitive. R is not transitive. So it means that R is neither symmetric nor transitive, but it is reflexive. So R is reflexive, but neither symmetric nor transitive. So option B is the correct answer.